Hello, everyone. My name is Robert Ronan. I'm a principal product manager here with the OCI Cloud Developer Adoption Team. Thank you for attending today's webcast, and thank you to Tara Van Clee for putting all this together. We have an amazing presentation today from the Rookout team. We have Oded Karet, VP of Product. If you have any questions during today's session, please put your question into the Q&A area. We'll also have a live Q&A session after the presentation. This webcast is also being recorded and will be made available shortly after the webcast. Before I hand things off to the Rookout team, I have a few slides of my own that I'd like to share with everybody. We're going to go over and briefly touch upon OKE, or Oracle Container Engine for Kubernetes. OKE is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. It's based on upstream versions supported by the CNCF, or the Cloud Native Computing Foundation. There's no vendor lock-in, and there's no need to re-architect your application when moving from an on-premise Kubernetes deployment to the cloud. If you look at the left versus the right on this particular slide, OKE is offered as a managed service. And that managed service, from an Oracle perspective, is manages scaling, high availability, upgrades, patches, software installation, basically everything from an infrastructure perspective. The benefits to this are faster time to deploy, better reliability, lower risk from a customer standpoint, and you as a customer get to spend your resources building applications and focusing on innovation versus managing the infrastructure. Oracle's cloud native services are built on top of OCI, or Oracle Cloud Infrastructure. These services can be categorized into a couple different categories: application development, operations, observability, and messaging. Oracle provides several cloud native services that, combined with OKE, give you a robust and scalable cloud native services environment. For example, fully managed Kafka, logging compatibility with Fluentd, native monitoring, notifications, events, and API gateway. Infrastructure as code lets you run your own Terraform stack in the cloud through our resource manager UI functions and several other services that will assist you with the most demanding workloads. And since OCI and OKE are based on open standard services, you're more than welcome to bring your own open source code and use alongside Oracle Cloud Native Services. This slide contains a few examples of what Oracle's been doing with respect to the open standard services community, supporting the Linux community in general. Oracle is a platinum member of the CNCF Foundation, or the Cloud Native Computing Foundation, and is a member of the Open Container Initiative Linux Foundation project. We are very serious when it comes to open standard services and supporting the Linux community in general. Oracle is the only major cloud provider to deliver and support a unified cloud native solution across managed cloud services and on-premise software, supporting a seamless bidirection and portability of cloud native application built anywhere. OCI provides bare metal, virtual machines, containerized compute, GPU for performance-intensive workloads such as AI or ML, and a variety of cloud storage options like block, object, file storage, and archive. OCI offers an array of services for developers to build modern applications with OKE, using OCI as the main platform for its services. We don't restrict users to a single programming language. You have your choice to use any programming language or framework that you choose, such as Java, Java Node, JavaScript Node, Python, Ruby, etc. And you can bring any DevOps tools alongside. Let's take a look at OKE and OCIR, Oracle Cloud Infrastructure Registry. OKE runs highly available Kubernetes clusters. It's developer friendly, it's enterprise ready, and offered as a managed service. And it keeps pace and compatibility with the CNCF ecosystem. OCIR is a container registry service that enables users to easily store and share their container images. This also allows users to pull images with Docker CLI and pull images directly into their OKE deployments. We've touched briefly about open source initiatives, OKE and OCIR. Let's talk about overall value. Let's break down the costing model at a high level. The area on the left designates the functions that Oracle manages for its customers as a managed service. Oracle manages etcd, master nodes, all the upgrades are supported through the Container Engine dashboard. And because of this, it's very easy to upgrade the OKE master nodes and node pool servers, and you control and decide when to do the upgrades. So as a customer, you manage the clusters, the worker nodes, and all this is done through your OCI account and tenancy shown here on the right. The pricing for the managed service is essentially at no cost, and it's offered on top of OCI. You, the customer, only pay for the compute, the storage, and the networking used in the data plane. So you're paying for the underlying resources to run OKE. What about persistence? How do you make sure that data is persistent with OKE? As you may know, applications can be categorized into two separate categories, stateful or stateless. Containers are well suited for stateless apps, but use cases may vary. Your app may require the use of external data source that stores for persistence, and OKE provides services and capabilities for both stateless and stateful apps. Your apps can easily integrate with databases such as ATP, access block storage, or even object storage. Finally, here are some highlights and new features that we've announced recently that I'd like to share with you. So Kubernetes 1.21.5 is now available, Cloud Shell, support for PVCs or persistent volume claims, container storage interface support or CSI support, and support for monitoring Kubernetes API using OCI audit service, autoscalers, HPA, VPA, and cluster. And with that, I'd like to hand it over to the Rookout team.
Thanks, Robert, and thanks to the Oracle team for having us. Who we are at Rookout, we see ourselves as the dynamic observability company. We deliver a platform that allows cloud-native debugging and live data collection. What that means for software engineers developing cloud-native apps is that we give them instant access to code-level data, which is critical in allowing troubleshooting of complex dynamic applications. And more on that in just a couple of slides. So we moved to Kubernetes. We moved to OKE, and we deploy much faster. We build a much more reliable application. We were able to reduce risk, and we innovate much faster. But bugs still happen, and problems still happen. And what happens when you need to debug a Kubernetes app? Debugging in Kubernetes or in microservices in general is a challenge. The applications are heavily dependent on configuration. And without being able to reproduce the exact configuration that the application seeing the bug encountered, you won't be able to reproduce the bug. Kubernetes is also heavily reliant on network. Microservices and pods interconnect, and any change to the network conditions may cause bugs and performance impacts that will just not happen when you try to debug locally. Data sensitive issues and things that only happen to a specific customer or to a specific account turn into a bigger challenge in Kubernetes environments. The code keeps changing. The versions of the code are changed much more frequently than in other traditional deployments. And keeping track of that and making sure that you are getting data from the right version of the code is a challenge. You need to know and understand how your app is deployed. And you need to be able to react quickly because the data keeps changing and troubleshooting becomes very time sensitive. So how do we try to address these challenges when we find a bug in our Kubernetes environment? Traditionally, we used to try debugging locally. Some customers are just not able to reproduce the environment locally. You never really debug a single pod. You never really debug a single service. You have to be able to recreate the whole infrastructure. And doing that on your laptop or even on a quote unquote private virtual machine is usually not something that you can do. Some customers fall back to script-based debugging or test-based debugging, which has its own limitation. And still, they depend on configuration challenges. If you are able to create a remote copy of your environment, or in extreme cases, some of our customers are able to log into the live environment, staging environment, production environment. If you're able to do that and you are using SSH, you may do more harm than good, and your security and compliance officer will definitely not be happy to hear that. Most customers fall back to traditional logging, printing everything from everywhere, ingesting it to a central logging service, and searching through it to find the root cause, which has its own additional cost, in a performance impact, in a dollar impact, and is very hard to manage, and it becomes harder the more your application grows and it becomes more complex. Logging has evolved into observability, and traditional observability tools do have their limitation as well. The main one is that in order to get an additional log line, in order to get an additional data point, you have to add code. You have to change code. You have to write code, wait for it to be deployed, wait for the issue to reproduce again, get some of the log lines, and then find out that you're still missing a log line, or that you're still missing some parameters that cause the problem to reproduce. And you have to change code over and over again, which is where we found our customers and where our customers find the current state of observability. The reliance on adding code for fetching additional data and needing additional data in order to be able to troubleshoot your application means that you spend minutes, hours, days, depending on the efficiency of your deployment, in between every single iteration of your troubleshooting effort. And when you have customers suffering a service lapse, or when you have pods dropping right and left, you just do not have that time to change code and add logs and wait for new data to show up on your observability platform. A much more efficient way to do that is what Rookout introduces as dynamic observability, is to click a button and get the data that you need. And that is our mission statement here at Rookout. And let's take a look at what we mean by that. I'm going to switch to my web IDE provided by Rookout. We are looking at the source code for a very simple to-do application running in OKE in a production environment. My customers are visiting a very simple to-do application, and they are adding more tasks and making sure that they can handle their to-do list. And everything gets updated in real time. When a problem happens, what I want to be able to do as a software engineer is first and foremost look at the code, see the code in what looks and feels like an IDE with the right background and the right font. And when I see something that looks suspiciously like the function that's in charge of adding to-do items, the next thing I want to be able to do is set a breakpoint. Now, traditionally, when we think of a breakpoint, we think of something running on our desktop, a single pod, and it's going to stop. But of course, we are in a cloud-native environment, which means that we don't have a single pod to look at, a single environment to look at. In fact, we have many containers running many different microservices, running in many different environments, each of them dynamically spinning up and down according to the required scale, with a different configuration, with a different version of the code. What I would like to do right now is to select a specific pod here, which I'm going to debug. And when I do that, Rookout automatically connects me to a running environment without having to rerun the app, without having to attach an SSH into a remote pod. I'm simply going to invoke an agent that is already running in OKE. And when I do that, Rookout is also going to automatically load the version of the code that's running in production. If you have ever tried to debug a production grade application, and you know that the version of the code keeps changing, you know that looking at a different version of the code means either not being able to fetch data at all, or being able to fetch the wrong data, which is maybe even worse. Once I'm looking at the right version of the code, I'm going to set a breakpoint at the entry point and the exit point of one of the services which it relates to adding tasks. And when I resume my production environment, I'm going to add another task. And as I do that, I hope none of you are blinking, because I'm going to add a task and the application is not going to stop. We're running in prod, we're running in OKE. Nothing is allowed to stop because other customers are still using the service. And yet, when I get back to my live debugger, I am able to see the entire debug snapshots just as if I was debugging locally. All of the data that I would expect to see in a local debugger was dynamically fetched from a live instance of the application, which means that if I was worried about the Kubernetes configuration, I do not need to reproduce it locally because I'm looking at the actual production environment. And if I was worried about reproducing network conditions, there is nothing changing here because I'm looking at the same environment. The customer data, all of those limitations that we mentioned as challenges and pitfalls that would stop us from connecting to a live environment, all of those do not need to be reproduced. And I have the data at my fingertips with a click of a button. On top of local variables and the stack trace showing me which application was invoked and which function was invoked on the logical flow to the code that I'm currently running, I also have metadata about the process and server, as well as tracing data provided by Open Tracing, which will provide me some more context about the microservices being invoked as my application is running. I am able to turn this data into log lines, which means that de facto, I can add log lines without adding code. And I can later pipeline these lines of log into my favorite observability platform. So rather than changing code and adding another line of code that says, write a log line here and wait for CI/CD to run, I am able, just as easily as local debugging, to add a line of code and pipeline this line of code to my favorite observability platform. So what have we seen? We've seen that we can take all of these things that stopped us from debugging live Kubernetes environments, things like Kubernetes, things like configuration, network condition, customer data, code versions, deployments, and time-sensitive data, and made them a non-issue. Because rather than creating a local reproduction of our environment, we were able to dynamically tap into the live production environment and get data straight from it. This gives us real-time context about what's going on in the application, which helps us solve bugs much faster. And solving bugs much faster keeps us efficient in working on delivering more features and more customer value. And of course, keeps our customers happy because they spend less time waiting for a bug fix. It makes us more efficient. It reduces logging costs because we only print the logs that we need rather than suffering logging FOMO and printing everything just in case. And in the bottom line, it creates happier and more efficient developers, which is what Rookout is all about. So do we have any questions?
We do, actually. So first question is, does Rookout have any limitations in regard to the runtime that you support?
That's a very good question. Rookout supports a wide variety of runtimes. We support most major runtimes used in production by backend engineers. Most of our customers use Rookout with Java, .NET, Python, Ruby, Node.js, and Go. And when I say Java, I mean JVM and all of its flavors. The same with .NET. We support C# and other languages. That's in terms of languages. In terms of cloud deployments, we support all major cloud vendors and all major deployments. Kubernetes is the most frequently used technology, but we also support serverless technologies and on-premise servers. So Rookout is really allows you to debug across platforms and across all major runtimes.
Excellent. This question actually may be closely related to the last one. Does Rookout work with any Kubernetes deployment, specifically private cloud appliance with OCNE deployment in mind?
So the general answer is yes. We haven't yet met a Kubernetes environment that we were not able to debug. In some cases, we are required to test it locally and provide a more detailed deployment example on how to set up Rookout. But on a general response, yes, we can debug any Kubernetes deployment.
Okay, awesome. Next question. When debugging a production environment, how does this affect the application, if at all?
That's an excellent question. Rookout was built from the ground up to be production grade, to be something that can be used to debug production applications running at scale. And that means being able to dynamically instrument the code using bytecode manipulation in order to very efficiently fetch code level data without stopping the app. In tests that we have executed and tests that our customers have executed before running Rookout in production environment, we see a performance hit of less than 1% in memory and CPU, because we make sure that to collect the data very efficiently and to pipeline it to Rookout or to a potential third-party observability platform in the most efficient method available.
Great. This next question is sort of on the fringe of compliance. So what happens to all the source code that's being uploaded? Where is it processed? Where is it stored?
Good question. I may have misused the terminology when I said that I can see the source code here in my browser. It should be noted that the source code is never uploaded to any Rookout server. The source code is loaded to your local client, to your local browser, either from your own desktop directly to the browser, or from your own source code management application. In this case, we are looking at GitHub, and we are fetching the source code directly from the SaaS-based GitHub server. But our customers use additional source code providers, either SaaS or on-prem, and the code is loaded directly from the source code management system to your browser without ever going through the Rookout servers.
Excellent, excellent. Those are all the questions that we received. Does anybody have any additional questions? I'll give another minute to put it into the Q&A. If not, we can close out. No? Any closing remarks, Oded?
No, just thank you for having us, and happy debugging.